Hi, so we're going to be solving simultaneous equations graphically in this video. So the first example, we've got two equations of straight lines. Y is 3x plus 2, which we're going to do in blue, and y is 7 minus 2x, which we're going to do in green. Now, if you're not sure how to plot straight line graphs, let's just assume we're going to do it with a table of values. So at the bottom there, I've started listing out the x values for minus 3, minus 2, minus 1, and so on a graph. And then we'll have some y's for the first equation, which I've done in blue, and some y's for the second equation that we've done in green. So the way I like to do this is that I usually always try and substitute the 0 in first. So if we substitute the x value 0 into this, 3 times 0 is 0, plus 2 is just going to give me 2, okay? And we know from our y is mx plus c generalized formula for straight line graphs that the number in front of the x is our times table that we're linked to. It's the gradient of the graph, so it's the times table that we're linked to in the sequence. So we're linked to the 3 times table. So this one is going to go up in threes. So that is 5, and then 8, and then 11. And of course when we're going down, it's going to go down in the 3 times table. So that's 2 minus, it's going to be minus 1, minus 4, and minus 7. And we think about the other equation, so 7 minus 2x, if we substitute 0 into that, 2 times 0 is 0, so 7 take away 0 is still 7. It's going to give us 7. Okay, and we're going up now in the, that's going to be the minus 2 times table. So we're going up in the minus 2 times table, as in we're going down. So that's going to be 5, and 5 take away 2 is 3, and then take away 2 is 1. Of course, going back the other way, we're getting bigger, so that's going to be up 2, that's 9, and 11, and 13. Now, some of these numbers will fit on a graph, and some may not. So let's have a look at this then. So, we've got x against y, minus 3, minus 7 in blue. So minus 3 is the x number, minus 7. I can't plot that because it's too big or too small in the y domain. So minus 2, minus 4 doesn't fit on either. That's okay, don't worry. Minus 1, minus 1. Now that fits on, doesn't it? So I'll put the x on there. 0 against 2, so x is 0, y is 2. 1 against 5, so that'll fit on. 1 against 5, and 2 against 8, that'll fit on, no problem. Okay. Put the ruler on, or my protractor in this case. Does it form a straight line? Good, because then we've done it right. So let's draw a straight line through the x's, and we'll do our green one now. So minus 7. No, it's the wrong one. Sorry, minus 3 against 13, well, that's not going to fit on. Minus 2 against, that's not going to fit on. Minus 1 against 9, that's not going to fit on. 0 against 7, I can do 0 against 7. That's going to be there. I'd do 1 against 5. Yeah, that's going to fit on. That's going to fit on there. And 2 against 3. That's going to fit on there. And 3 against 1 is going to fit on. Put my ruler against the x's. Do they form a straight line? Yeah, I've probably done it right. And then we draw the line, and where they cross over, they must be simultaneous. Now, unusually, we've actually got 2 points that we've calculated from substitution that actually sit right on top of each other. Normally you'd get some kind of you'd have to read the decimals off the graph. In this particular case, it just gives us the coordinate 1, 5 as a simultaneous point. Okay, so 1, 5 is our simultaneous point.